Unit 7, Physical Behavior of Matter, Lesson 7, The Combined Gas Law. How are pressure, temperature, and volume calculated using the gas laws? By the end of this lesson, you can convert between units of temperature and pressure, and you can determine the relationship between temperature, volume, and pressure. So do now. So the combined gas law takes those three gas laws we talked about in our last lesson and just puts them together. So this is really all you really need to know about the gas laws. If you can use this formula, then you're good to go. And you can find it on table T, where pressure is equal to, or P is equal to pressure in kilopascals or atmospheres. The V is equal to the volume in liters, milliliters, or centimeters cubed. And K is in T is the temperature in Kelvin, always in Kelvin. And what this gas law essentially says is if I start at an initial pressure, volume, and temperature, I can calculate what I'm going to be at a final pressure, volume, and temperature. So let's go into some examples. How to use the combined gas law. You have to make sure all temperatures are in Kelvin. So that's the very first thing you have to do. You have to make sure you use the same units for both volumes and for both pressures. So you have to be consistent. If one variable remains the same, then leave it out of the equation. So this makes it easy for us if something is constant. Before you do that, you have to know how to convert between kilopascals and atmospheres to make sure everything's in the right unit. So what you can do is just set up a proportion using table A, because table A says that 1 atmosphere is equal to 101.3 kilopascals. So that's standard pressure. So if I'm at 0.92, okay, here's the example. What is the pressure in kilopascals of 0.92 atmospheres? I know that 1 atmosphere is equal to 101.3 kilopascals, and I want to know what 0.92 atmospheres is equal to in kilopascals. So that's my proportion. Just cross multiply. So x is going to equal to 101.3 times 92. Therefore, my x is 93.2 kilopascals. So now you try. Okay, and you also have to do the same thing in temperature. So if I'm given something in Celsius, I need to put it back into Kelvin. So you should recall how to do this from heat in the beginning of the year, table T. K is equal to degrees Celsius plus 273. So if I have at 33.7 degrees Celsius, how many kelvins is that? I'll just plug that into my formula, and I get 306.7 Kelvin. So now you try that. Oh, they should have a degree symbol here. Okay. Now an example of our combined gas law. A gas in a rigid container has a pressure of 3.5 atmospheres at 200 Kelvin. Calculate the pressure at 273 Kelvin. So some things you need to take note in these types of questions. 1, a rigid container means my pressure is constant. My volume is constant, excuse me. My volume is constant. Volume equals constant. So that's a key phrase to look for. If I have a rigid container, my volume is constant. So if I have anything constant, I can take it out of my combined gas laws formula. So essentially, all I have is P1 over T1 is equal to P2 over T2. The next step is you probably want to list everything that you have been given in the formula. So if I'm starting at 3.5 atmospheres, that's going to be my P1. It's equal to 3.5 atmospheres. And I'm starting at 200 Kelvin, 200 point Kelvin. So those are my two initial temperatures. They want to know the pressure at a different temperature. So that's going to be my unknown, my second pressure. And then my second temperature is 273 Kelvin. So because both of my temperatures are in Kelvin, I don't have to convert anything. I'm in the place I want to be. So then all I have to do is plug everything into my formula. So I'll have 3.5 atmospheres over 200 Kelvin. That's going to equal my P2, which is going to be my unknown, over 273 Kelvin. So then if I cross multiply all this, I'm going to take 3.5 times 273. So So I'm just going to cross my 273 up here. I don't need to cross anything else because P2 is now by itself. So then I'll just take that number and divide by 200. And that will give me my final pressure. My P2 is equal to 4.78 atmospheres. That's going to be the same unit that I started with. And then you can do a check. If I increase my temperature, I know that I'm going to increase my pressure. So my pressure that I started with is higher than is lower than I started with. So notice how if I increase my temperature, my pressure should also increase. And that looks like a good check. A second example, a 32.9 liter sample of a gas at constant pressure increases in temperature from 25 to 45 degrees Celsius. Should the volume increase or decrease? And calculate the new volume. So I have a constant pressure. I have 32.9 liters. It wants to know if I increase my temperature, what's going to happen to my volume? Now recall, if I increase my temperature, my volume will also increase. So I should see an increase in my, I circled the wrong one. I said increase and circled decrease. I should see an increase in my volume. So let's calculate it. My first pressure and my second pressure I can take out. At constant pressure, they get removed. So my first volume is 32.9 liters. That's what they gave me. And my first temperature is 25 degrees Celsius. My final volume is what I'm looking for, and my final temperature is 45 degrees Celsius. Now recall, in order to do this, we must be in Kelvin. So we need to convert both of my Celsiuses to Kelvin. So I'm going to take 25 plus 273. So in Kelvin, this is 298 Kelvin. And then 45 plus 273, this is equal to 318 Kelvin. Now, if I plug all those numbers into my formula, I'll have 32.9 liters divided by 298 Kelvin is equal to my final volume over 318 Kelvin. Sorry for the big mess. This is hard to write in. Now, cross multiply 318 times 32.9. I just cross it up, and then I can divide that by 298. And this will get me my final volume is equal to 35.1 liters. My fives are always so ugly. I'm sorry. Okay, 35. And as we saw, that is an increase in volume due to an increase in temperature. All right, I will do one more example, and then you're on your own. A 45 milliliter sample of gas at standard pressure is heated from 20 degrees Celsius to 50 degrees Celsius. The pressure of the gas increases to 107.9 kilopascals. What is the new volume? So this doesn't look like I have anything constant. So that means I need all of my variables. So my first thing is I'll list everything. My P1 is at standard pressure. So that's going to be 101.3 kilopascals. The reason I picked that one is because my final volume, my final pressure, is also in kilopascals. So I'm going to leave it in the same unit that I started with. My original volume is 45 milliliters, and my final volume is what I'm looking for. My beginning temperature is 20 degrees Celsius, and my final temperature is 50 degrees Celsius. Now recall, I need to put those both in Kelvin, so I'm just going to add 273. So that makes this 293 Kelvin, and then 50 plus 273 is equal to 323 Kelvin. Now I'm going to leave the rest for you. I want you to try this out. What you're going to do then is just plug in our 6 variables. We're going to actually I'll do it for you. I'll plug them in for you, but then I'll let you solve. 101.3 times our initial volume is 45. Make sure you put your units. I'm out of space, so I'm just going to cut my units. Is equal to 107.9 times V2 is what I'm looking for, over 323. And then as a check, I want you to find your answer on your own. Okay, now do a couple more calculations to check your understanding. Here's your combined gas law up at the top. Do a couple calculations, and I'll go over this in class. All right, so now you can convert between units of temperature and pressure, and you can determine the relationship between temperature, volume, and pressure using our combined gas law.